Hello juniors, today we're going to see the last electronic assignment corresponding to our subject logic and statistics. We're going to see the last part of the normal distribution. We're going to learn what the inverse normal distribution is about. And after this, we're going to be practicing with lots of exercises about all of the different topics we have covered throughout the year in logic and statistics. So, objectives for today's class. Number 1, represent the normal curve distribution in a diagram, which is something you should already know from previous classes. And number 2, calculate expected values by applying inverse normal curve distribution, which is the new thing we're going to learn about. Okay, so what is the inverse normal distribution? It says, here we are given a cumulative probability, so we're given a probability as our data for unknown z, and would like to find the z value that has this cumulative probability. We're going to see what this means in a second through the examples. For example, the owner of a company that fills cartons of juice to a mean volume of 150 ml may wish to find the volume below 5% of the cartons are in order to reject them. So we have the mean in this case, and we have a determined probability which we wanna avoid, because having cartons with less than 150 ml is not the best thing, right? So we're gonna reject those. Then it says, again, we can use a calculator to help us find this value. The calculator has an inverse normal function, which will do this. I'm gonna show you how to do that in a second. We will look first at inverse normal calculations using the standard normal distribution, which, if you remember, standard normal distributions are the ones which have a mean of 0 and a standard deviation of 1 always. Okay, so let's see how this works. It says, given a standardized normal curve distribution, use your calculator to find the value of A. So look at how these problems are a little bit different. For part A, we want to find the probability, or actually we're given the probability, but we want to find the value of this A over here, which produces a probability of 0.877, which is 87.7%. So let's make a sketch of what's happening here in order to understand this. If we draw a normal curve distribution, as always, it's a bell-shaped curve, something like this, right? Let me do this a little bit better. Let me see. Kind of. Okay, let's use this one. Okay, so if you take a look at this, we're looking for a value A, which produces an area below the curve of 87.7%, right? And we're talking that C should be a value less than that. So the mean is always in the middle, right? In this case, the mean is 0 according to our information. So we know that for left of this, we have 50% of the information. So if we want a value A, which should give us a probability of 87.7% to the left, because we're talking about values that are less than that value A, then you should notice that the value of A should be somewhere to the right, okay? So here we would probably have the value of A. Remember, this is only a sketch. This is not 100% precise. So what we're saying with this information is that, let me shade this blue region here, that this blue region over here, the area below the curve, must be of 87.7%, right? So this area over here is 87.7% of the information. This is how we correctly interpret our information. So we want to find what this value must be in order to produce this area. How do we do that? Let me write here some steps that you need to follow, and then I'm going to show you this in the calculator. You would go to menu. If you have your calculators with you to follow this, it'll be better. You go to menu statistics, then you go to distribution, norm again. But now, instead of clicking on NCD, which is what we were using in all the previous examples, we're going to click on INV-N. Why? Because we're given the probability as our information, and we're looking for this value. We're doing the inverse or the opposite of what we were always doing. Okay, so let me show you what that looks like in the calculator. So if you take a look at the calculator, we would go to menu statistics, and you're going to click on dist F5. the norm, which is F1, and here you have NCD and INF. Remember this NPD, we're not using NPD in normal distribution. We're only using these two. So you're going to click on for inverse of a normal distribution. So you have this information. In some cases, you may have here list, but you should change, data should always say variable, okay? So then you have the question, the tail, is it to the left or is it to the right? If you look at the sketch we just did, the tail is to the left, right? The tail is where the shaded region is going to. It's going to the left or to the right. And in this case, it's going to the left, okay? Then for the area, we're going to write the value of the area. In this case, we need to write it as a decimal, right? 0.877. It's the probability that we have below the curve, right? 0.877. The standard distribution is 1 and the mean is 0. Once we have completed all of those values, we click on execute, and there we have the value of A, which in this case is 1.16. And you see that this value makes sense with the exercise because we said that our mean was 0. So the value of A must be a value greater than 0. And we get a value of 1.16, which is completely logical for the problem. Okay, so this is correct. And you see here, I'm putting a picture of what you need to plug in the calculator to remember. Okay, so I'll leave that there. Now, let's see part B. Part B says the following. We want to find the probability of C being greater than A, and the probability is equal to 0.2. So we're going to have kind of a similar situation here. Let me copy this. But now you should see that the tail would be to the other side. Let's see why. When I erase this value of A is also eliminated. There. So we're going to say that now we want to look for a value A where C is greater than that value and the probability is 0.2. So if C should be greater than a value A, which produces a probability of 20%, you should also recognize that the value of A should be somewhere to the right. Why? Because we're saying that we're looking for this value A for which all the values above are producing a probability of 20%. So that shaded region over there is the one that in this case must be equal to 20%. Okay, that's what we interpret when we read this symbology over here. Okay, so we already know what to do. In this case, we're gonna write as our tail. You see that the tail in this case is to the right. Okay, so we're gonna write tail to the right. Our area would be 0.2, which is 20%. And the mean and standard are the same. So the standard is equal to 1 and the mean is equal to 0. If you plug in all of that information in the calculator, let me show you. I'm going to go back, then tail should be to the right, so we click on F2. The area is 0.2, standard is 1, and the mean is 0. We click on execute, and there you have the value A, which is 0.842. Again, you see that this answer is completely logical. It's a value which is greater than 0, which means that we are on the right place. Okay? Finally, for part C, we have this situation. We're given the information that the probability of C being in between negative A and A is equal to 0.42. So I think you can already imagine what this sketch would look like. Let me copy the normal. We're going to do the sketch. If we do the sketch for this situation, I'm going to eliminate this. And now we're going to say that, see, there. Now we're going to say that we're in between two values of A, right? So we're saying that there's a value of A right here, for example, which would be negative A because we're to the left of the mean, and another value here, which is A. Theoretically, the distance between the mean and negative A and A should be the same, right? Because we're talking about the same value A. That's why actually this distance over here must be equal to this distance over here, but we're just doing a sketch, so it doesn't matter much for the sketch. So basically what we're saying is that the probability in between these two values, which is all of what we have in the middle, this shaded region over here, is the one that should be equal to 42%, right? According to this problem. So this, let me see. There, this is 42%. Okay, so how do we do this in the calculator? In this case, you would see that we have another option in the calculator for tail. In this case, it's not right nor left. In this particular case, you see that there's no tail, right? So we put the third option we actually have in the calculator, which is central. So you put tail central. The area would be 0.42. And the standard deviation and mean are the same. 1 and mean is 0. So if you put all of those values, you would see that you will be, let me show you that in the calculator. If we go back, instead of tail right, you see that we have a third option, which is central, F3. So you click on the area, which is 0.42, and standard and mean are the same. You click on execute, and you see that you get two values. One, which is for negative A, which is equal to 0.553. You see that the two values we obtain are the same, but with different signs. And the value of A would be 0.553. So those are my two solutions for this case. Actually, we're only asked to find the value of A, so the value of A would be 553. This is the answer for this situation, okay? I think this is clear, right? It's kind of easy, actually, if you pay attention to what you're being asked. Okay, here's a summary of the steps you need to follow in your calculator in case you want to read this, in case you don't remember how to do something. There's an extra exercise here, I think. Yes, I think this one over here is a new one, but the process is exactly the same. So if you want to check this out, in order to understand how to use your calculator, you have that available. Okay, so let's see the following example. It says, given that x, the variable x, is normally distributed with a mean of 15 and a standard deviation of 3, or variance of 9, determine x when the probability of x being less than x is equal to 0.75. Okay, so this is a very similar situation, right? Let's write down our information. Or actually, we could do the sketch first. If we're asked for the probability, let me write that down, probability of x being less than a given value of x, which is 0.75. If we do the sketch of this, the sketch would look something like this. It's not necessary to do the sketch always, but I always like doing it because it kind of makes the resolution much easier and comprehensible, right? So in this case, our mean is 15. Remember, this first value corresponds to the mean, and this second value corresponds to the variance. If you take the square root of that, you're going to get the standard deviation. Okay, so this value is 15, and we're looking for a value x less than x, which has a probability of 0.75. That means that this value of x should be somewhere to the right of the mean, right? So somewhere around here, I would put the value x. And I'm looking for that value such that all of this area down or below the curve represents 75%, right? So I want to write here that this is 75%. Okay, so with this sketch, we know exactly what we need to do. We would have to go to the calculator and write as our tail, we're going to write to the left in this case, right? Tail left. The area would be 0.75. The standard deviation is, in this case, 3, and the mean is 15. So the only thing that actually changes with respect to the previous example is that we change the values of the standard deviation and the mean, okay? So if we go back to the calculator, we're going to put tail to the left. The area is 0.75, the standard is 3, and the mean is 15. Click on execute, and there you have the value of x, which produces this probability. So 17.02 would be the value of x. And you see that it's completely logical. It's a value greater than 15, which means that we actually did this correctly, okay? So easy, simple exercise. Now let's see the following. Example. It says cartons of juice are such that their volumes are normally distributed with a mean of 150 ml and a standard deviation of 5 ml. Again, we have the mean and the standard deviation. So let me write that down. The mean is 150 and the standard is 5 ml. It says 5% of cartons are rejected for containing too little juice, so much less than expected. Find the minimum volume to the nearest ml that the cartons must contain if it is to be accepted. So you see that this is kind of a real life application, right? One can determine experimentally what the mean would be and what the standard deviation would be. Actually, if you're producing 150 ml cartons of milk, you would expect that your mean value for the milk inside should be 150 ml, right? If it's not that value, maybe you're doing something wrong. Okay, so let's make a sketch of this. If we're saying that we're going to reject 5% for containing too little juice, then our sketch should look something like this. We're going to have the normal distribution. The mean in this case would be 150. And 5% are rejected. So maybe a value around here, I'm going to call this X. From that value and below, we're going to have a probability of 5% of cartons that we're going to reject. Okay, so this represents 5%, which we reject. Okay, so once we have done the sketch, solving this is easy, right? We're going to write that our tail in this case would be to the left. The area would be 0.05. Remember, you should always write this as a decimal number. Then we already have the values of standard deviation and mean. So if we go to the calculator, we're going to write that the tail should be to the left. The area is 0.05. The standard deviation is 5 in this case, and the mean is 150. We click on execute and we get the value of X. It says to the nearest ml, right? So the complete answer would be, or not complete, right? But the not rounded answer would be 141.8 ml. But the rounded value would be to the nearest ml, 142 ml. That means that 5% of all of my production would have, or I would expect that 5% of my complete production would have a volume less than 142 ml, and I will reject all of those. So that kind of talks about something bad about the enterprise, right? Because they're saying that, well, they are rejecting the ones who are 142 ml or below, right? But what about all of these values over here, which are in the middle? You're selling to your customer cartons of milk which contain less than 150 ml. But you should at least provide them 150 ml if they are paying for 150 ml, right? So this kind of talks something bad about this enterprise. So that's something that you can analyze through this tool, the normal distribution, okay? Okay, so let's see now another example. We're getting into more challenging example. I think we have this one and one more. Yes. So let's see, it says, sacks of potatoes with mean weight 5 kilograms are packed by an automatic loader. So this is a mean weight. So we're given as an information that the mean is 5 kilograms. Then, in a test, it was found that 10% of the bags were over 5.2 kilograms. Use this information to find the standard deviation of the process. So you see that in this case, we do not have the standard deviation. So what will happen in this case? If we don't have mean and standard deviation, we cannot use our calculator because our calculator requires us to plug in a value for mean and standard deviation, right? So if we cannot put any information for the standard deviation in this case, then there's something that we need to do in order to be able to actually use our calculator. Okay, so let me write that here. I cannot use the GDC in this case because I do not have this information. So how should I solve this? Let's make a sketch of the problem first to understand what's happening. sketch of the problem. If I do a sketch of this situation, we're saying that 10% of the bags were over 5.2. So we're saying that if we do the bell-shaped curve, something like this, we're saying that the mean is 5, and we have 5.2 to the right, so 5.2 would be, let me do it a little bit more here. 5.2 would be here. So we're saying that 10% are over that weight, okay? So this blue shaded region here represents 10% of our information, according to this problem. Okay, so in this type of problem where I do not have the mean or the standard deviation or neither, I will have to apply the concept that I talked to you about in the previous class, which is about the standard normal distribution. So let me write this here: standardized normal distribution. The standard normal distribution, remember, it's the variable c, which will always have a mean of 0 and a standard deviation of 1. We're doing this kind of to make an extrapolation of the values of this problem into a standard normal distribution to be able to solve this, okay? Why can we do that? Because at the beginning of normal distribution, if you remember from the first electronic assignment we saw about normal distribution, we said that one of the characteristics of normal distribution curves is that all of the curves have the same shape and characteristics, okay? So that's exactly what we're gonna have. Let me write that down. We're using this property, has the same shape and characteristics. Remember the characteristics were that they were symmetrical with respect to the mean, they all have a bell-shaped curve and all of that. So all of the normal curves have the same shape and characteristic. So shape and characteristics as the previous sketch. There you go. So if I do the same sketch I did for the problem, but now changing my information for mean and standard deviation, we're gonna have that the mean now is 0, and we will need to find a value c, let me call this a value c, where the probability of being above that value c is of 10%, okay? But now the difference is that we have the value of the mean, which is 0, and we also have the value of the standard, which is 1. So I will be able to find this value c, which I will later use to relate it to this value of 5.2. That's the idea of the standardized normal distribution. So we're gonna find this. We are looking for a value c. Actually, this should be capital C, where the probability of being above it is 0.1, which is 10%. So using our GDC, we're going to follow the same steps that we did before. We're going to write that our tail, in this case, would be to the right. Tail right. Our area, the area we're looking for is 0.1. The standard deviation is of 1, and the mean is of 0. We're using the standard normal distribution to solve this. So if you go to the calculator, we would plug in those values. Tail to the right, area is 0.1, standard deviation is 1, and mean is 0. So you click on execute, and there you have a value of c. So using all of this information, we get a value of c, which is equal to 1.28. So this value c is 1.28. But then, how do we relate that? 1.28. How do we relate this value to this 5.2 we had here? Well, if you remember from the beginning, from the previous class actually, I showed you a formula that relates the value c with any other normal distribution. If you remember, the formula was like this: x minus mean over standard deviation. That formula, if you check the formula booklet, is available here. It says standardized normal variable C equals x minus the mean divided by the standard deviation. Obviously, these values of the mean and the standard deviation are referring to the original set of data, okay? So now that we have calculated the C value, we're going to say that the C value is 1.28, 1.28, and this is equal to, we are relating 1.28 with 5.2, so 5.2 will be this x value I'm writing here, 5.2 minus the mean of the original data, which is 5. And you now see that my only variable is the standard deviation, okay? So I can solve for the standard deviation, and we're going to get as a result that the standard deviation is equal to, this is 0.2 divided by this value over here, which is 1.28. So if you perform this in the calculator, you will get the standard deviation, which in this case is 0.156 kilograms. So this is how we find the standard deviation of this problem in case we do not have it in the original data, right? We need to work with the standardized normal distribution in order to be able to solve this. Okay, so finally, we're going to see this last example. We're basically going to apply the same concept. This is the most difficult type of exercise that you could get for this type of problem of normal distribution. It says, a manufacturer does not know the mean and standard deviation of the diameters of ball bearings she is producing. So we do not know either, right? In this case, mean nor standard deviation. So mean, we don't know it. Standard deviation, we don't know. But we have this information. It says, however, a sieving system rejects all ball bearings larger than 2.4 centimeters and those under 1.8 centimeters in diameter. It is found that 8% of the ball bearings are rejected as too small and 5.5% are rejected as too big. What is the mean and standard deviation of the ball bearings produced? Okay, so we're given those two pieces of information from which we can create two equations that will let me then calculate the value of the mean and standard deviation. Here you see the hint, which is what I talked to you about from last example. It says, you must be able to standardize a normally distributed random variable in order to find unknown values of the mean and standard deviation. There is no way to find these values directly from your GDC. So we will have to apply this concept of standardizing a normal distribution to be able to solve this. Okay, so first of all, let's make a sketch of what we know from the problem. We do not know mean or standard deviation, so I will make a standard normal curve distribution to show the information we have. The mean, we do not know its value. I'm going to write it as mu. But we know this. 2.4 are the, it says, it rejects all ball bearings larger than 2.4. So I would assume, let me check. It says that 2.4 are the largest one, right? And 5.5% are rejected for being too big. That means that 2.4 should be somewhere around here, 2.4. And that 5.5%, let me do this with orange maybe. This area over here should be equal to 5.5%, right? So this is 5.5%. And then we know that 1.8 are the ones who are 1.8 or below are also rejected, and those represent 8% of my information. So 1.8 should be somewhere around here. This is 1.8, and I will reject those who are below this diameter. So all of this, which are below, are going to be rejected, and all of those represent 8% of my information. So this is 8% of my information. Okay, so this is all of the information I have for this problem. So since I do not have in this case either of the mean or standard deviation, I will have to standardize this yes or yes to be able to solve this. So standard normal distribution. Remember, C with a mean of 0 and a standard of 1, always. So we standardize this information. I'm going to copy and paste this normal distribution and change the values to C values. Let me use the same spot there. So here we would have as mean, we would have 1, and these values both change. The mean would be 0, sorry, not 1. So here we would have a C value, C1, let me call this, and this would be C2. So we're going to focus on finding C1 and C2, and then we're going to relate them to these two values we had before. Okay, so for C1, we're going to say the following. For C1, we know that for C1, the probability of C being less than C1 is equal to 0.08. So that's the value of our area. So in this case, the tail is left. The tail is left. The area would be 0.08. Then the standard deviation is equal to 1 and the mean is equal to 0 because we're talking about a standard normal curve distribution. So with this information, I can find the value of C1, right? So we're going to have that C1 is equal to, if we go to a calculator, let me see, tail to the left, area is 0.08, the standard is 1 and the mean is 0. So we get this value, negative 1.41 is our value of C1. Okay, now we're going to do exactly the same thing for C2. In this case, we have that the probability of C being greater than C2 is equal to 0.055, right? 5.5%. So in this case, our tail is to the right. To the right. The area would be 0.055, and the standard deviation is 1, and the mean is 0. So with this information, we're going to find the value C2, which, if you go to a calculator, would be equal to, this is right, 0.055, and we get this value, 1.60. 1.60. So we found these two values, C1 and C2, and now we're going to relate both values to our original data in order to find mean and standard deviation. Okay, so once again, we're going to go to this formula. C is equal to x minus the mean over standard deviation. I think you should already see where this is going. Remember that this formula is available in the formula booklet. You don't need to memorize this formula. Okay, there you go. So for C1, we're going to say that a negative 1.41 must be equal to, for x, we're going to write the respective x original value, which is 1.8. So 1.8 minus the mean over standard deviation. And this would be our equation number 1. This is our first equation. We have two variables here, mean and standard deviation. Now for C2, we have the same thing, right? 1.60, the value of C2 is equal to the respective original value, which is 2.4. 2.4 minus the mean divided by the standard deviation. Okay, so you see that we have two equations with two variables, right? If we have the same amount of equation and variables, it means that we can solve this. The easiest way I see we can solve this is leaving, in both cases, the standard deviation alone. If I rewrite this, I would say that standard deviation is 1.8 minus the mean over negative 1.41. And if I do the same thing here, standard deviation is equal to 2.4 minus the mean over 1.60. Then we can equate this with this, right? Because standard deviation is the same in both cases. So if we equate both things, we're going to say that that 1.8 minus the mean divided by negative 1.41 must be equal to 2.4 minus the mean over 1.60. 1.60. So we see now that our only variable here is the mean. So we need to solve this in order to find the mean. So if I, for example, take this up here and take this up here, then I will avoid having a denominator. So this would be 1.60 times 1.8 minus mean. This is already algebra. This is not probability anymore. So this is negative 1.41 times 2.4 minus mean. So then we distribute these values and we get that 2.88 minus 1.6 mu is equal to negative 3.38 plus 1.41 mu. Okay, then if we keep on solving this, we're going to get that if we reorganize terms, I want to take this to the right and bring this to the left, then we're going to get that 6.26 is equal to 3.01 mu. So finally, we will get the value of the mean, mu, is equal to 2.08 centimeters. If you take a look at our information from the beginning, you would see that 2.08 makes sense with the problem. 2.08 is a value in between 1.8 and 2.4. So that means that the value is logical, okay? So that's our mean. But now we need to find the standard deviation. To find the standard deviation, we can plug in this mean we just found into this formula, for example, or into this formula. I'm going to plug in the second one, which looks a little bit easier. So we're going to say that the standard deviation is 2.4 minus 2.08 divided by 1.60. Divided by 1.60. So if you solve this, we're going to get the standard deviation, which would be equal to 0.2 centimeters. And that's how you solve this type of problem. You see that it's quite long, but if you understand what you're doing, you'll see that it's easy. It's very easy, okay? And this is, as I told you, the hardest example that you could get for this particular topic. Okay, so I hope this was clear, juniors. If not, please let me know. We're going to clear doubts in future live sessions. Thank you for your attention and see you.